This is Mr. Barron. I'm going to be doing another problem involving the common ion effect. What we have to do in this problem is calculate the ion concentration and pH of a solution that has formic acid. Formic acid is a weak acid, and it has this structure. So it's in equilibrium with hydrogen ions and its conjugate base, which is CHO2 negative. All right. Now, if you want to follow along with this, this is a practice exercise from page 724. All right, so now, how do I figure this out? I do know the Ka, and I know the starting concentration of something. Oh, and I also know the concentration of formic acid. So the starting concentration of formic acid is 0.05 molarity. All these values need to be molarity. I usually sometimes skip them just because my numbers and letters get really mixed up sometimes. But it's always good practice to keep it in molarity, so I'll be doing it with you. All right, and then it says we have acid added to this. So the acid that we have added to it is nitric acid. Now, nitric acid is different than adding the conjugate base like a previous example I did. And the nitric acid completely, notice I don't have a back arrow, completely ionizes into hydrogen ions and nitrite ions, or the nitrate ions. Now the nitrate ions are not the conjugate base to this acid, which is called formic acid. But the hydrogen ions, they do have an effect. So I have to actually, whatever the concentration I have of the nitric acid, which in this question is 0.10 molarity, that has to go here, 0.10 molarity. The reason it has to go there is because that acid that I've added initially starts off with that much hydrogen ions. Then of course the conjugate base, this is a weak base, or this is a weak acid, so I'm starting initially with 0 of this. Alright, then I have a change. Obviously this acid decreases by a value x. The hydrogen ions increase by a value x, and the conjugate base ions increase by a value x. So now I'm going to do my 0.05 molarity minus x, and then I have 0.10 molarity plus x, and then this value is just x. And I do know my Ka. My Ka for this particular equilibrium expression is 1.8 times 10 to the negative 4. Okay, so that is going to be equal to these two over this. So it's 0.10 molarity plus x times x over 0.05 m minus x. Just like the previous conjugate or the common ion effect problem I did, these x's, the difference between this molarity, and because x is so small, these numbers are not going to change very much. The reason this doesn't get set to 0, this x that I haven't circled, is because it's being multiplied. If you're just doing addition or subtraction, the comparison between this molarity and that x is going to be so small because x might be 1 times 10 to the negative 4. It's just such a small value. These two x's, we can assume 0 for our calculation. We'll still get really close. All right, so I'm going to solve for x like I have in many other problems. So I'm not going to show the math for it. Watch a previous problem in dealing with equilibrium if you want to see how I rearrange it. So I've got this, and I'm multiplying it by the concentration, 0.05, and then I'm dividing it by 0.1, and then I have my x. My x in this problem is 9 times 10 to the negative 5th. Now the question's asking me for pH, which is the negative log of hydrogen ions. Now, I can't stick this number in for hydrogen ions. Remember, this number substitutes in for x here, which at my equilibrium will tell me my hydrogen ion concentration. So I actually have to add 0.1 to this number. So I'm adding 0.1 to it, and then I'm going to take the pH of the negative log of my hydrogen ions, which is 0.1, and I do that in my calculator. Oops, don't need the second button, so it's just going to be negative log answer, and then I should have my pH, and my pH is pretty much 1. And that's the answer you're looking for. If you're looking for the concentration of formate ions, which is the second part of the question, well, my formate ions are right here. That's my formate ion, so that's the same as X. So this is the other part of my answer, which is the value of X, which is also the concentration of the formate ions. And there we go.